Welcome to Brain Vision.
Now we start off with a spring with a non-Hooke's law spring, right? It doesn't obey Hooke's law. We want to find what is the potential energy function. We can do that by looking at the work done. And so work done by a force is given as the initial potential energy minus the final potential energy, which in this case is just the integral of the work done by the force Fx dx from x equals to x1 to x equals to x2. Now we're gonna let u1 and x1 be 0. Then in this case we will find negative u2 at some arbitrary x equals to integration of 0 to an arbitrary value x. Fx, in this case we're going to substitute the expression in, so there's a negative phi x is beta x squared dx multiplying the negative over to the right hand side. This is just b ux, right? So b integration from alpha x plus beta x squared dx so get alpha over 2 and so this is our expression for potential energy for this particular spring. Now we want to find what is the speed of the object when it's at a certain position after the spring is stretched. What we will need to find is the change in the potential energy of the spring, and this must correspond to the kinetic energy that is actually imparted to our object. So we change in the potential energy. We take the initial potential energy, which is at when x is equals to 1 meters, right? So x is 1, we get alpha 2 plus beta over 3 minus the final position, which is when x is 0.5 meters. So alpha over 2 substituting alpha to be 60 and beta to be 18. Our change in potential energy, we should be able to calculate 36 minus, we should get 27.75 joules. This must be equal to the kinetic energy of our object. And given that the object is 0.9 kilograms, we just have to divide the mass over and take the square root to get the velocity to be 7.85 meters per second.